I think that this is one of the funnest parts of ham radio because with these components, you can build anything that comes to your mind. However, if it's not your thing, it's only 4 questions of the test. You can miss them all and do just fine. So, but feel free to just shout out any questions you have. I don't like a whole lot of formality, so however you feel comfortable interacting is fine with me. The less formal, the better in my book. So the first question, and you can just interrupt anytime. What electrical component opposes the flow of current in a DC circuit? And the name of that, the resistor, kind of helps you to remember that that's opposing, it's resisting the flow of current. And if you think about the symbol of a resistor is a squiggly line like this. So an easy way to remember that is if you've ever had kids that like to pinch the garden hose while you're trying to water, that's resisting the flow of the water as it goes through your garden hose. So you can imagine if the kids kink the hose a whole bunch of times, making that symbol, the flow would be pretty resisted. And that'll help you to remember that. It's 47 in the PDF, and printed wise, I'm not sure where that comes out exactly. 47 also. Those maybe are scheduled later. But we're on 47, sub-element T6, T6A. Yeah, everybody able to find it okay? That first question talking about a resistor? Okay, great. Any questions about a resistor? Easy to remember? So question 2, what type of component is often used as an adjustable volume control? And the answer to that is potentiometer. And if you can imagine a resistor, but if it has a wiper that goes from one side to the other, as it moves farther and farther into the resistor, you get more and more resistance. Can you kind of imagine that if you had our original resistor symbol, and then you add an adjustable arm on it that goes from one side of it to the other? Now it becomes a variable resistor, and that's called a potentiometer. And you could use that as a volume control because the more resistance you add in an audio circuit, the quieter the audio level would be. So is that clear? Any questions about that one? So question 3, what electrical parameter is controlled by a potentiometer? And we kind of already talked about that. It's resistance. So on one side, the resistance will be minimum. I don't know if you can see this clearly enough, but see up here, this is a kind of a symbol that we're talking about for a variable resistor. And if you're looking in your book, this is the wiper that's adjustable. So as you hook up to these 2 wires and you move this arm all the way down here, there's very low resistance. And then as it gets farther and farther through this resistive material here, you get lots of resistance on this side. And then the other 2 pins is the exact opposite. So when it's all the way to the right, you'd get minimum resistance, and when it's all the way to the left, you'd have maximum resistance. And you can remember the symbol because it's our up and down resistor symbol that we originally talked about in the previous question with the addition of the wiper. Any questions about that? Okay, what electrical component stores energy in an electric field? And the answer to that is a capacitor. And some people find it helpful to think of a capacitor as a super tiny battery. It'll store just a tiny bit of energy. Not enough to power much, but that's kind of electrically a little bit how they work. So you can charge them up and then you can discharge them, and then you can charge them up and you can discharge them. So they have the tendency to smooth things out. If you put some noise into that's, you know, oscillating up and down into a capacitor, it'll kind of charge the capacitor and discharge, and that noise will kind of get flattened out through the capacitor, and a little bit of it can pass through, and you can combine different sizes of them to make tuned circuits, and we'll talk about those later, I think, maybe in a different section. But a capacitor is formed relatively simply. In its simplest form, it's just two plates. And that's how you recognize the symbol. Right over here, you can see the symbol is just wire coming in, a plate, another plate, and the wire coming out. Easy enough. Any questions about a capacitor? So question 5, what type of electrical component consists of two or more conductive surfaces separated by an insulator? And that's capacitor. And I like these little pictures because capacitors, as you can see in the examples, they come in a whole bunch of different packages, depending on how much capacitance they need. And so when you're looking at a circuit board, you'll be able to see all of these, from, you know, great big ones. If it's a very old power supply, we don't see those much anymore. They're too expensive and they're not as common anymore. And then the really small ones, and then these are probably what you'll see most often because they're the least expensive. But if you were to rip open one of these cans, what you'd see is essentially those two plates that we talked about inside the symbol. It's just two plates, but then in order to save space, they roll them up into a roll. Yes?
I don't have any background in electrical theory, so about a capacitor, when would that be needed? When do you need that tiny amount of energy to do what?
It's usually for filtering noise or tuning a circuit.
That's it.
Yeah, in most cases. Trying to think of a good example that's not one of those cases. One case that you would probably all have in your pocket that's a more innovative use of capacitance is the touch screen on your smartphone. The reason it can sense your finger is it's building a little bit of capacitance between the tip of your finger and the screen. And when that is generated on the screen, it can tell where your finger is and if it's tapping or not. So that's the way those screens work, is it's sort of a capacitor, and you'll find them in natural places too. Like, for example, in this room, you could sense the capacitance between the floor and the ceiling. And by using that, you could detect whether, for example, someone has walked into the room. It would slightly change the capacitance of the room. But in its most common form, they're very, very small, and it's literally two metal plates really close to each other. And depending on how much surface those plates are and how close they are to each other, it changes the capacitor. And so they make lots of different types of them for tuned circuits.
Okay, so then you would have different qualities capacitors.
Absolutely, Yeah.
Okay, to get different outcomes of your buffering, so to speak.
Right. Yep. And what they essentially do is they store a tiny bit of energy. So if you have noise coming in, you'll have energy, no energy, energy, no energy. Well, if you run that into a capacitor, on the high spot, it'll kind of charge it up, and on the low spot, it'll kind of drain it down. And so you end up with a reduction of that noise. But you can also use it to create a signal by allowing to discharge the capacitor at a certain time and then use it to create a signal. So when you combine them in a lot of different ways, they become very useful. But that's kind of at the heart of tuned circuits. And I think we'll talk a little bit about those later. Any other questions on capacitors? They're a real fun component. So this is one that you probably built as a kid and maybe didn't know it. Question 6, what type of electrical component stores energy in a magnetic field? And that's an inductor. And you can see with the pictures that essentially they're just a coil of wire. So I don't know if when you were a kid you ever took an old nail and you wrapped wire around it. But if you did that, you were making an inductor, but when you put energy into it, it'll create a magnet. If you put a magnetic field near it, it'll create electricity. So the inductor interfaces between the electrical realm and the magnetic realm. So next question is the same thing stated differently. What electrical component is usually constructed as a coil of wire? And that's an inductor. Any questions about inductors? And the way you can kind of remember what that is you can induce a magnetic field into an inductor or out, either way. If you put energy in, it'll make a magnetic field. If you put a magnet near it, it can make an electrical field. So they're used in all kinds of places. The reason they're important to amateur radio is for their ability to create tuned circuits. But another very common place is inside transformers. So if you look on your utility poles where you've got a really high voltage line running down the neighborhood and you want a lower voltage coming into your house, what's the big can that's sitting up on the pole? Anybody know? It's what? They're filled with coolant, yep. But that's a transformer. And what's inside of that is basically 2 inductors. There's one with a whole bunch of turns of wire, and then another one right next to it with less turns of wire. And so they're magnetically coupling energy from that high voltage line into a low voltage line for your home to consume. So a transformer is just two inductors that are placed right next to each other, and they're magnetically coupling that energy through. And they fill them with oil to dissipate the heat better. Any questions about inductors before we move on? They didn't have a picture of the electrical symbol. We might see that later, but it looks just like a coil of wire, kind of. You'll recognize it. All right, what electrical component is used to connect or disconnect electrical circuits? And you've probably all seen switches. You touch them every day in your homes. I like this picture right here, this knife switch. because that gives you an idea of what's inside of all of these. And it's literally a strip of metal and another strip of metal, and when they touch, the switch is on. When they don't touch, it's off. And because they're a mechanical device and kids like to flip them up and down, you know, they wear out over time. But they're very inexpensive and easy to replace and simple to operate. The letters underneath these looks like they're printed backwards, but there's lots of different types of switch. So the simplest one is a single pole, single throw, meaning it's just one piece of wire and it's either open or closed. When you get, so this blue one right here, next to it is the same single pole, single throw, but inside a package so you can't see the guts. And then you've got a single pole double throw with 3 wires, and essentially what that is you've got 2 wires and one in the center, and the switch can either be connecting these 2 or connecting these 2, if that makes sense. So it's only, you know, one mechanical switch, but it's got half of another one right next to it, and you can have it on this side or on this side. So if you imagine, like, you, for example, want to have a red light, green light, you might use a single pole double throw switch, so that when you switch it to one side, the red comes on, and when you switch it to the other side, the green comes on. But either way you switch it, there's one light on. Does that make sense? And then the double pole double throw is the same as that, but you've got 2 of them in one package. So a total of 6 wires. And you might use that, say, in the same red light, green light example. Maybe you want to have, you know, red, green, and orange and white, but you always want 2 lights on. You know, you always want the red and the yellow, or the green and the white. Any questions about switches? Use them every day. Life would be kind of difficult without them. What electrical component is used to protect other circuit components from current overloads? Yeah. So nowadays, a lot of times we use circuit breakers, but in at least in your home, you would more commonly see a circuit breaker. Circuit breaker and a fuse are both serving the same function. It's just a fuse, after it trips, you throw it out and replace it with a new one, and a circuit breaker, you reset it. Anybody have questions about the difference between those two? A lot of times sensitive electronics prefer a fuse over a circuit breaker, just because they can trip a little bit faster, and they're less expensive to manufacture. That gets frustrating though if you're wiring your radio up backwards and the fuse keeps blowing and you can't figure out why, and you've gone through a whole box. Well, one real important thing to remember in that situation: don't switch it to a bigger fuse. The minute you do that, your very expensive radio is toast. The engineers have very carefully selected that size of fuse to protect the device. If the fuse is blowing, it's because something is wrong. So when your circuit is designed for a 2 amp fuse, if you put in a 10, you're either going to cause something to catch fire, or you're going to hurt yourself, or at the very least damage your expensive radio. So they're not interchangeable. They'll fit in the hole, but they're not interchangeable. If it calls for a 2 amp fast blow, that's what you need. In a super pinch, you might get away with putting in a smaller one, but that probably isn't the best idea either. But if you go larger, you're going to start a fire or hurt somebody. Any questions about fuses and why they're important? All right. Which of the following battery types is rechargeable? And the answer is all of these: nickel metal hydride, lithium ion, and lead acid gel cell. Your phone in your pocket has which type of battery today? Yeah. Why did they pick lithium? Anybody know? They're dangerous. They catch fire. They explode. Why did we want them? They're more expensive. They're small. They hold a lot of energy in a small, lightweight space. You've got it exactly. Yep. So the fact that they're dangerous and they catch fire and they're expensive, oh, we don't care about that. We're using lithium. Everybody wants small and sexy, right? So there you go. We got lithium in our pocket. Lead acid, that'd be like your car battery. But this question lists specifically gel cell. What's the difference between a regular lead acid and a lead acid gel cell? Anybody know? Usually, yes. Yeah. The other, you can add water to it. But literally, it's the acid inside has had an additive put in it so that it's a jelly. So if the battery gets turned upside down or something, it's not going to spill out on the floor and burn holes through stuff. But with that, you get a little bit less efficient battery. Nickel metal hydride, that's kind of what we used before we started to accept lithium ion. Any questions about batteries types? Which of the following battery types is not rechargeable? And the answer to that one's carbon zinc. If you go into the dollar store and you get the big package of 9 batteries for $1, those are carbon zinc. It's the lowest cost battery on the planet. They don't store much energy, but for the right device, you maybe don't care, you know. You're just trying to get a battery in that toy or whatever for a couple of minutes, and then you can't stand the sound of it anyway. So give those kids the carbon zinc battery. That toy will be done in just a few minutes, and then you can put it away and get them a fresh one the next time. All right, now we move on to semiconductors. This semiconductor kind of changed the world. What class of electronic components uses a voltage or current signal to control current flow? And the answer to that is transistor. Transistors are the backbone of pretty much any modern chip-based component. The transistor can be arranged in a lot of different configurations. They can be used as a switch, like for example, if you want to have a really low signal controlling a very large signal. You can use them as an amplifier. You can build them into voltage regulators, all kinds of things. The transistor is incredibly useful component. Essentially what they are is they're sort of 2 diodes, but the center is built into the same device. Any questions about a transistor? We're probably going to talk a little more about them as more questions come up. But as you can see from these pictures, they come in all different package styles. But a common way to identify them, not in every case, but in many cases, the fact that they have 3 leads on them is generally a giveaway that it's probably a transistor. If it isn't that, it's probably a voltage regulator or something. The only way to know for sure is to type that number on it into Google and find the data sheet for it. What electronic component allows current to flow in only one direction? And that's the diode. The diode is an amazing device because, you know, when you're talking about power supplies, our mains voltage coming in from the power plant is an alternating current signal. So if you looked at it on an oscilloscope, you'd see the power switching polarity. You could measure it at positive in one instant and it'd be negative in the next instant. And then right in the right spot, there'd be no power at all. And that sine wave that you would see would oscillate from up to down 60 times per second. That's the reason they call it alternating current, is because the way that those electrons are flowing, they're changing direction and going the other way 60 times every second. And our electronic devices, like our radios, primarily operate on direct current, meaning that the electrons need to be flowing the same direction all of the time. So if you've got to have, imagine if you were using a switch to switch that, you'd have to open and close that switch and exactly time it with the 0 point of that 60 cycle wave. It'd be impossible to do. Well, a diode does that because the current will only flow through it in one direction. So you can use diodes to take all of if you imagine the top half of the wave, and then you use a diode to take the bottom half and flip it up, and then the bottom half and flip it up. Well, now you have a pulsating DC. Now, what component did we talk about earlier that can smooth out a signal that's kind of pulsating? Yeah, boy, you guys are sharp. I wasn't sure if anybody would get that. Great. So there you got basically the guts of a power supply. A diode to get it to DC, and then some filtering components like a capacitor to smooth it out and make it nice and constant. And then a voltage regulator to keep the voltage just right. So diodes incredibly useful. Which of these components can be used as an electronic switch or amplifier? And that's the transistor. We kind of already talked about that. Which of the following components can consist of 3 layers of semiconductor material? And that's the transistor. And I like that they made a little picture here. But can you guys see my mouse, or is it better when I stand up and point at the, okay. Well, essentially what you've got is one half of this is a diode and the other half of it is another diode. That's basically what makes up a transistor. But you'll know it's not a diode because there's 3 connectors on it, and a diode will only have 2. Which of the following electronic components can amplify signals? And that's the transistor. How is the cathode lead of a semiconductor diode often marked on the package? And that's the little stripe. And if you looked back up at the symbol up here, notice the cathode is minus and the anode is plus. And I always have a trouble remembering that, but the stripe looks most like a minus sign. So when you get hooking up your light emitting diode, then you know that the cathode side goes to the negative. If you put it in backwards, it just won't light. And why won't a light emitting diode light if you put it in backwards? Because a diode only conducts in one direction. So if you put it in backwards, it just sits there. No electrons flow through it, therefore no light emits. So the stripe is useful to know which way to hook them up. And here comes the, I already gave this one away, but LED light emitting diode. And they're just like other diodes. The only difference is they emit light when the electrons flow through them. Any question about light emitting diodes? They're kind of a fun component. They last forever. They use very little electricity. They've replaced almost every incandescent lamp in our whole world. Unless people just want an incandescent lamp for the nostalgic nature of it, they almost don't exist. So they definitely changed the world. FET, field effect transistor. And you'll notice the symbol kind of looks like a transistor, but it's made all boxy. What are the names of the two electrodes of a diode? And the answer for that is anode and cathode. Does anybody have a good way to remember that? Because 20 years and more in this business, I still struggle with it. I check myself on Google if I ever need to know.
You can always say A plus.
Oh, there you go. I like that.
Yeah.
A plus, anode plus. Thank you. That'll help you on the test.
Okay.
Which of the following could be the primary gain producing component in an RF power amplifier? And that's the transistor. What is the term that describes a device's ability to amplify signal? Gain. So this is unrelated to this section, but let's take just a second to talk about something. What's better, a signal that's amplified with a transistor, or creating more power, or getting a better signal by building yourself a better antenna, and why? Does anybody have any guesses?
Build your antenna.
Yeah, well, an antenna is always better for a couple of reasons. It gives you more signal with no increased noise. Anytime you amplify a signal with a transistor, yes, you get more signal, but the noise that was in there with that signal also gets amplified. And so that's the reason that, for example, if you've got a hearing aid, you probably know that even though they've improved a lot over the years, they pick up a lot of noise. Well, that's why. They've got a transistor in there amplifying a signal, but it's not only amplifying the signal you want to hear, it's amplifying everything else that's in the background that you don't want to hear. So you're just in this sea of loud. Well, guess what? A better antenna doesn't do that. A better antenna picks up more of the signal you want and rejects the signal you don't want. It's kind of like focusing a flashlight. If you set a candle on a table, you know, and you look at the light that's coming off of that candle in all directions, you can tell there's light, but what happens when you put an array of mirrors and you focus that like a, a miner's lamp in the olden days, that you'd have your little flame burning there, but you have the reflector. Well, now you get more light out the front. Your antennas can do that. So there's a couple of advantages. One, more signal with less noise. Two, no electricity bill to pay to run that transistor. And it's a whole lot of fun to build them. If you get into building antennas, that's one of the funnest parts of this hobby. So a good antenna is always worth more than an amplifier. Any questions about that? Okay. What is the name of an electrical wiring diagram that uses standard component symbols? And that's a schematic. And there's an example of the schematic here in T1. And we kind of talked about the resistor. You can imagine that as a garden hose kinked a whole bunch of times, restricting flow. We've talked about the transistor here in figure 2. And this looks like a lamp of some kind, and then a battery. So what is component 1? The resistor. Component 2? You figure you'll be able to remember those? You think of the garden hose and that it's resisting flow. And figure 3 is the lamp, and number 4 is the battery. So these days, you pretty much wouldn't ever see a lamp. You'd see a light emitting diode there instead. And the symbol for a light emitting diode will be similar to the regular diode, but it'll have little photons coming off of it. There may be a picture of one later, I don't remember. All right, what is component 6 in figure T2? Component 6 right down here. That's a capacitor. Now, an interesting thing about the capacitor symbol, sometimes they'll be drawn with the plates flat, and sometimes they'll be drawn with one of them curved. It doesn't matter.
Does that indicate direction?
It can. Mm-hmm. Yeah. A lot of them, though, they're not polarity specific anyway, so. What is component 8 in figure T2? Light emitting diode. So we do have a symbol for one. Yeah, right here. You'll notice the symbol is just like the diode, but it's got the little photons emitting off it to symbolize the light emitting out of it. Component 9 is a variable resistor. You'll remember the resistor is the kinked garden hose looking thing with the addition of this adjustable wiper on the outside edge. What's the name for another name for variable resistor? Can anybody remember? Starts with a P. Potentiometer. Excellent. What is component 4? That's a transformer. So we remember when we talked about inductors, you got an inductor on one side and an inductor on the other side. And one side will be your high voltage side. In this example, the high voltage side is on the left and the low voltage side is on the right. And the difference between the two, if you tore it open, there'd be more turns of wire on one side than the other. and you can flip them around. You know, if you take a step down transformer and you want to use it to, you know, shock your cows and keep them in their pen or whatever, you just can flip it around and hook her up. It'll turn that voltage real high. What is component 3 in figure T3, variable inductor? So you can remember that because it's just the inductor symbol, which looks like a coil of wire, with the addition of this adjustable wiper on the symbol. So it's an inductor, and the wiper says it's variable. Our favorite thing, component 4, is the antenna. Why do we like antenna gain better than transistor gain? Noise. And it's free lunch. You don't have to pay the power bill for it. Any questions so far? All right. What do the symbols on an electrical schematic represent? Electrical components. Which of the following is accurately represented in electrical schematics? The way components are interconnected. The components are all real common, but how you hook them up will make completely different devices. So that's the reason we have schematics, is to take what one person thought of and share it with somebody else.
I have a question. In the average radio, you just find like one resistor and one capacitor and,
No, there'll be hundreds of everything.
oh really?
Yeah, they've gotten very complex. But you can usually look at the numbers on them and figure out what the components are. And you can a lot of times download the service manuals that'll have the full schematics in them. But repairing them anymore, they're mostly, the components are so much tinier than the ones that are in these pictures that it's almost impossible to surface mount for most people to solder. They don't have, you know, steady enough of a hand or the right tools to really do much repair.
Most of the boards are layered.
Say that again.
Electronic boards are layered.
They are.
Maybe 12, 13 layers there.
Yes, and you might have a burn trace in the middle of one of them. And sometimes you'll see little jumper wires going around on the circuit board to repair that. Which of the following devices or circuits changes an alternating current into a varying direct current signal? Rectifier. It's another name for a diode. Usually rectifiers, the most common configuration that you'll see them in is what's called a bridge rectifier. And all it is it's a diamond of 4 diodes. And the reason they put 4 is it makes it a lot more efficient. If you had only 1 or 2 diodes, you'd be throwing away half of your energy. You'd get your pulse, and then this one wouldn't go through, and then you'd get your pulse, and this one wouldn't go through. Well, we don't want to throw away half of anything. So if you put 4 diodes, then you salvage all of the signal. So the most common in any circuit is a bridge rectifier. It's an arrangement of 4 diodes. What is a relay? It's an electrically controlled switch. So you got your electromagnet, or your coil of wire, or your inductor, and that electromagnet is pulling down the switch arm. Now we less and less are seeing relays in things because the same function can be done and never wear out using what component? You remember? What semiconductor has 3 wires on it, starts with a T? Yep. In a lot of cases, the transistor can replace the relays at a much lower cost, and they never will wear out. What type of switch is represented by component 3? A single pole, single throw. Component 3, so it's a switch, but you'll notice it's only got 2 connection points and the switch in the center. Single pole, single throw. That's the simplest type of switch. Now here they're showing the other types. Single pole, single throw, single pole, double throw. This is the example where we talked about hooking up a red light on one and a green light on the other. Different types of switches. Which of the following displays an electrical quantity as a numeric value? Meter. And you got old analog meters and newer digital meters. These are getting impossible to find because they're too expensive to make anymore. What type of circuit controls the amount of voltage from a power supply? A regulator. Now this is that exception. It has 3 wires and it looks like a transistor, and there are transistors inside of it, but it doesn't function like that. It's a voltage regulator. Its function is, if say you've got a battery, you know, maybe a 9-volt battery, and you want a 5-volt, real constant 5 volts. A battery, it'll be 9 when you put it in new, and then it'll drop down to 8, and then 7, and then 6. Well, you don't want that varying voltage going through to your sensitive electronic circuits. So the voltage regulator will take the 9 in and put a smooth even 5 out. And as it drops to 8, smooth even 5 out. 7, 5 out. Voltage regulators are fantastic. Before semiconductors, that was kind of difficult to do. What component is commonly used to change 120 volt AC house current to a lower AC voltage for other uses? The transformer. It's just a coil of wire, an inductor on one side and an inductor on the other. And I like this picture because it shows that one side will usually have more loops and the other side have less. So you got your primary winding and your secondary winding. Which of the following is commonly used as a visual indicator? A light emitting diode, LED. Which of the following is combined with an inductor to make a tuned circuit? And that's the capacitor. And here's 2 examples of tuned circuits. Why do we care about tuned circuits in amateur radio? Exactly. Yeah. Yep. There's a lot of radio signals out there, and we usually only want to listen to one at a time, or we maybe want to scan them, but still it's, you know, we're checking this one and checking that one and checking this one. Well, it's these tuned circuits that allow you to ignore all that noise that's out there, filter it out, and listen just to what we want. So tuned circuits, very important. It's all about filtering the noise. What is the name of a device that combines several semiconductors and other components into one package? And that's an integrated circuit. And these are basically just thousands and millions of transistors arranged in a particular way. Transistors and diodes. What is the function of component 2 in figure T1. So that's the transistor here, and it's controlling the flow of current to turn this light on and off. And guess what else you could do? You could change this resistor into a variable resistor and make that light go bright and dim. Which of the following is a resonant or tuned circuit? An inductor and a capacitor connected in series or parallel to form a filter. So here's our capacitor, there's our inductor, here's the resistor, and here's the voltage series resonant circuit. And then here's the same thing, but instead of the capacitor and inductor being in series, meaning you flow into one and out of that into the other, it's in parallel. See how they're placed parallel to each other rather than series to each other? Any questions about parallel and series? This has minimum impedance at resonant frequency and maximum impedance at resonant frequency. So if you only want to let one particular signal through, which one of these would be most applicable? Minimum impedance at resonant frequency. If you want one signal to come through loud and clear, this one. If you've got a super loud radio station that you're trying to always block out and you want to let everything else through, build this one tuned to that radio station, and the radio station will quiet down so you can hear everything else. Which of the following is a common reason to use shielded wire? And that's to prevent coupling of unwanted signals to or from the wire. Remember how we talked about how an inductor is made? It's just a whole bunch of wire, and you magnetically induce signals onto it. Well, if you have a big long wire running, 8 or 10 miles from your house back to the telephone office or whatever, well, guess what? That's a big long inductor hanging out there, and signals will cut their way onto it and come riding it right into your house. So how do you prevent that? You wrap some more wire around it, and then you got the wire you want your signal on in the center, and you want to have your shield on the outside. Now all that stray energy hits the shield first and gets bled off to ground, and the signal you want stays nice and clean in the center. Does that make sense? And that's it. We're finished 25 minutes early. You guys didn't have enough questions.
A shielded wire, is that like a cable for my cable TV and stuff like that?
Yeah. Mm-hmm. You've got, in that case, it's working a little bit differently. You're sending your energy down the center, and you're using the shield both to block external, but as well as keep your signal on that center. So usually when they talk about a shielded wire, there'd be multiple wires with one shield around them. So it's a little bit different than a coax, but similar. More questions?
You put a resistor in a circuit, is it steal energy?
Absolutely. Where does that energy go? Yes. I don't know if they had a picture of our resistor types. Let's see if we can find them. Yes. What do you notice about all these different resistors? It's a little hard to imagine in a photo, but some of these are great big and some are really, really teeny. Well, why is that? Because a real big one, it'll dissipate more heat than a little tiny one. So, what is your hair dryer at home? It's a great big resistor. It gets red hot and you blow air across it and there you go. Same thing with your crock pot. What is it? It's a great big resistor. You turn it on high, it's resisting a lot. Heating all kinds of a good chili or whatever. It's a good question. Yeah, nothing really disappears. If you're resisting something, it's got to go somewhere. It's coming out as heat. In the case of an LED, that lost energy, it's coming out as photons, the light. Good questions. Anything more?
Yeah, I've got a drone. I got a battery. I have the charger, and it's got the 3 prongs. Is that part of the transistor?
No. That's one of those wires, I'm forgetting what they call it, but I think it's a sense wire. And what it's doing is it's helping your charger to intelligently charge that battery. In the old days, we'd charge our batteries with 2 wires. You know, think of the jumper cables you put on your car. You know, there's only 2 wires. But if you can adjust the charger to be just what that battery needs, the battery will last longer and you'll have less lost energy, less chance of starting a fire, you know, a lot of advantages. Yeah, well, you got to be careful when you're charging lithium. So they have very sophisticated charging circuits for most of our modern batteries. And that 3rd wire is giving feedback so that the charger knows, hey, how's that battery doing? Can we slam it with a whole bunch more energy? Or is it getting almost to the top and we better slow it down a little bit and you know, top it off nice and slow? If you're filling a big old jug and you do it at full speed all the way to the top, what happens at the end? You know, it overflows, makes a mess. But if you're filling it up and you get close to the top and you back the tap down and then you just dribble in the top, full jug, no spillover. You can kind of oversimplify a sophisticated battery charger to that same way. It's slamming the battery with all it can take when it's safe to do so, and then when it isn't, it's backing it off and doing it nice and slow. Have you noticed that your phone will charge from 20% to 50% really fast, but from 95 to 100, not quite so fast? That's why.
So what happens when it gets to 100%?
It does.
So that wire is a memory.
Yeah, it's sophisticated control for the charging circuit. Yeah. Now, how they did that with a single wire, I couldn't tell you. I didn't work in that department. But I'll tell you, it's amazing, and it does make a big difference. You know, your batteries didn't used to be as useful as they are today. They're still kind of cruddy. You know, as soon as we come up with a legitimately good battery, the gasoline vehicle as we know it will be history for sure.
That's what Tesla's running on.
That's what they're hoping.
The lithium batteries.
Yeah.
But they're like the size of a AA battery.
Well, there's a lot of them.
Well, yeah, there's thousands.
Yeah. Yeah. They do that just to be efficient in the manufacturing process. But yeah, in my opinion, we haven't found the best battery yet. That's still coming. And it'll be a big game changer when we do figure that out. Because if you've got a great way to store energy that's very efficient and cheap, what changes? Well, now electric vehicles cost less and drive further than gas vehicles. That changes a lot of industries around us. If you've got a real efficient storage system, why do you need to generate your power in Delta and ship it to California? You don't. If you got super efficient storage, collect it from the sun and store it right there on your own property and use it the next day. But with lithium batteries, who wants to do that? You know, they're expensive to buy. They're going to be crap in another 5-7 years. You're going to be buying new ones again. It's cheaper to pay them to burn the coal in Delta, ship it 2 states away to California. So once we get a good battery, a lot will change in our world. I think that'll be one of the biggest things.
I think it's how they charge it.
Yes.
I went to the Long Beach Grand Prix several years ago, when I was the first racer that was all electric. And I couldn't understand how they could go so far on those batteries, because those batteries weren't as good as they are now.
Yeah.
And it was a braking system. Every time you put on a
Regenerative braking.
brake, the energy back into the battery.
Yes.
And I thought that works, I had no idea.
Well, remember when we talked about inductors, how you can get magnetic energy out, or you can take energy in. Well, that's what's happening. You've essentially got a motor, and when you turn the motor backwards, it's generating electricity and putting it back into the battery. Oversimplification, but that's the concept.
All the testing courses that way now.
Yes. Yeah, why throw away energy? Because the biggest problem with an electric car is that your battery. So, hey, what do you do to supplement that a little bit? Well, don't throw the energy away when you're stopping. Save that for later. But eventually, someday, we're going to have a good battery, you know, even better than lithium.
It's like people out there are staying away from getting an electric car because they don't go that far without charging.
Yeah. It gets better every year, though. It's definitely improving. But the game-changing thing will be, I think, a whole new battery type. You know, what that'll be, I don't know. But I'm excited to see it because I don't think we're far.
And radio, that'll affect everything.
It will. Yeah, it'll affect a lot of stuff. Batteries are a big darn deal. Any other questions?